Hello everyone, Mr. Stolle here from your tutors. I just want to firstly encourage you guys to subscribe on our YouTube channel so that you can be the first one to receive any update when we upload our work. Okay, so let's look into quadratic functions today. It's our lesson number 2 where we're looking at quadratic functions. Okay, let's dig in and find out. You know how I like to do this. I want to start the questions first so that you can see if you have an idea. If you don't, you know this class is actually for you. You have to listen attentively. Then come back and attempt the question here. Okay, so let's find out what you guys need to understand. So now when you're talking of quadratic functions, it's in the form of y is equals ax squared plus q. Okay, so let's give an example. The mother graph is y equal to x squared. Okay, let me just use my pen there. The mother graph is equals to y equal to x squared. That's what we know. But now we want to see how it looks like. Okay, so we have got something like that. Okay, that's our x-axis, that's our origin, that's our y-axis. So the graph actually it's like this. Okay, now so this one here is graph of y is equals to x squared. Now how does your a affect the graph? So this a have what you call the vertical stretch. Okay, it stretches your graph. So vertical stretch. So it has to, so when a is above 1, when a is above 1, your line will be close to the y-axis. Okay, so for example here, if we are to have y is equal to 2x, so if you attended lesson 1 on quadratic on linear functions, you now understand what I mean by this. Now it has to do with the gradient. So like for example here, it's y is equals to 2x squared. So it's more steeper than the normal mother graph. What about if it's a fraction? Let's, for example, let's give it let's widen it. So in this case here, we are saying this can be y is equals to half of x squared. So what is happening there is that it widens. So when it's a fraction, it widens the graph. When it's above 1, you know that it actually shrinks your graph or stretches up, and it will be close to the y-axis. That's what we're talking about here. So that's, if you had to draw this two graphs on the same set of axes, what will happen is that that's where you actually be able to tell that this one is actually wide and this one is narrow and everything. But if I just to draw maybe graph of y is equals to x squared, you can't tell if it's just a sketch, you can't tell whether it's supposed to widen enough or shrinks. No, it doesn't matter there. It's just you have to draw the shape in correct order. What about when it comes to when a is not above 0? So when a is above 0, what happens is that, just a quick note there, when a is above 0, we know that our graph should be smiling. When a is less than 0, your graph will be frowning there. So what is happening here is that this will have what you call a minimum turning point. Minimum turning point. Then here, when it's about, when it's a graph of our a is above below 0, it's negative. It means that it will be having a maximum turning point. Okay, that's what we need to know there. Now let's see how it looks like when it's a negative. When it's a negative, it will be facing down. So when it's negative, it faces down like that. That's how the shape looks like. When a here, a is above 0, but a here is below 0. Okay, so that's how it, so this is more like y is equals to negative x squared. But we do the same thing again. If let's say this is equal to, let's say our a is actually above what call 1 as well, what will happen here is that it's going to be y is maybe equals to negative 3x squared. And if it's gonna be out there, it means that it's actually a fraction, which makes it what called to open more, like that, to widen. So y is going to be equals to maybe negative half, negative third x squared. That's what we're talking about here. Now, let's also talk of the shape of the graph. Now, when we have the shape, this kind of shape here, and let's say we've got this kind of shape here, again, this is a turning point. This is a turning point. Let's have our equation here. Our a, we know that it's gradient as well. So here, y is equals to ax squared plus what called plus q. This here is also our act as our gradient. Okay, act as our gradient. So what we are saying here is that not necessarily, let's not refer to as a gradient for in this case. Okay, let's say here, if you are to have to talk of the gradient here, the gradient here is 0. So let's just talk of the gradient as m. Okay, okay, like here, for example, here, gradient at turning point is equal to 0. Okay, so but now we want to know what happens before we reach the turning point. So in this case here, we are saying this part here is what called is this part here. What is happening here? The graph is decreasing. So meaning to say the gradient is 0. It's negative. It's negative. Okay, so we are saying here gradient is the f of x. Say if it is graph, we say f of x is actually decreasing. And in this part here, from turning point until infinity, f of x will be increasing. Then here, this has to start with the increase because of the positive gradient. Then here it's also a decrease. So here decrease, here it's increasing. Okay, now let's say, for example, your turning point, the turning point is actually, maybe let's say here the turning point is what called 0 and 3. Okay, let's say it's a turning point. The coordinate there, it's actually 0 and 3. So in this case here, we are saying where it's increasing, let's say this point here, turning point is actually 0, 3. So when talking of increasing here, it will be x okay. Where it's increasing, it will be x less than 0. What about where it's increasing? It's going to be x greater than 0, because we refer to x value. So if it's going to be turning point as 0 and 3, it means that what call our increasing, where it's increasing, it's below 0. Or in this case here, it's going to be above 0. Or you can say it's x element of negative infinity to 0, like that. Or in this case, it can be x element of what call 0 to positive infinity. That's what we need to understand there. That's how you define what call where your graph is increasing or where graph is decreasing. Now let's move on to this what you call to ax squared plus p plus q. Now I want to see how does your q affect your graph. Your q is a vertical shift. Okay, vertical shift. So this is up and down. So we can either shift our graph up and down by q units. Okay, that's what we're talking about here. So your q does have nothing to do with the what call your shape of the graph. It just shift your graph, whatever shape that you have, it just have to shift it up or down. Let's say, for example, here we have got f of x is equals to, maybe let's say, x squared plus 2. So when it's x squared plus 2, we know that from our knowledge now, x squared is the mother graph. Now, when it's x squared plus 2, now it means that it's starting from where? Starting from 2. It's turning at 2, sorry. So here it will actually be 2 units up. So in this case here, we have got to remember, don't forget to put your x, to label your x-axis and also the center there. So this graph here will be actually 2 units. So we are having 2 there. And here it's 0, the original one. So this one here is y is equals to x squared. But the transformed now, we have transformed it by how many units upward? 2 units upward. So we are saying it's y is equals to x squared plus 2. What about if it's if we are going to put it down here, let's say it's negative, it means that here, let's say it's negative. Then here y will be equals to, let's say this turning point, it's 5, negative 5. It means that your graph will label it as y is equals to x squared minus 5. Y minus 5 because you've shifted the original graph, the mother graph, 5 units below the x-axis. That's what you have done there. You have shifted it 5 units below. But again, if it's that maybe you are sketching, you must remember to find where it's cutting. But we'll talk about it today. Now, let's now come back again to what we call the domain and range here. Let's understand also domain and range. Remember what we said in lesson 1 when we're doing when you're doing linear functions. We know that domain, these are input values. But input values of what? X values. So domain, it has to do with X values. What about range? These are output values. So when we're talking of range, we are talking of Y values. Values occupied by your graph. Y values occupied by the graph. X values occupied by the graph. Let's say, for example, let's talk of let's take what we call the graph of y is equal to what we call x squared. Y is equal to x squared. Now, or let's say have another graph here. Let me just save another graph here. I just want to add another graph. Sorry guys, I want you guys to understand more. So let's say we have another graph facing down there. But remember, it's coming from, maybe let's put here negative 6. But now we are saying this will be y is equals to negative x squared minus 6. Negative meaning to say it's facing down. Okay, then minus 6, we have shifted it 6 units downwards. That's what we're saying here. Now we have got these 3 graphs that we have here. Now let's look, how do you define their domain and range? Let's start with the mother graph. We're going to start with mother graph. So let's start with mother graph, y is equals to x squared. Now with the mother graph, the domain here in this case here, domain is going to be equal to, it can actually occupy any value of x. It can occupy any value of x. That's what is happening here. So we can just say here, x element of real numbers. Okay. Or we can say for x occupies negative infinity to positive infinity. That's what is the range there. What about the domain? What about the range? The range now, we are now restricted, guys. Look here what we're having. Let's look at x squared. Can we see what's happening with the y values here? It's only occupying y values, the positive y values, but down here it's not going down here. It's not, you are not finding it down below the what call the x-axis, or what we say the negative side of y. So it means that you are going to say, okay, for your range, it's gonna be y greater than what is it, 0. Because we are saying the graph here occupies values that are above 0 only on top. The graph occupies only y values above. Now, let's go to the next what is it? Next equation there. Let's have, what is it? Y is equals to x squared plus 2. Okay, let's talk of the domain for this one. Now, domain, remember, domain will always be x element of real numbers, because it occupies any value in the, what is it, what you call in the in the x-axis. It occupies any value. So this graph here can go to negative infinity. This also side can also go to negative infinity in terms of x. Okay, so, or we can say x element of what we call negative infinity to positive infinity. Now, what about the range? The range in this case here, we are saying it's occupying values from 2 going upwards. So it's occupying values from 2 going upwards. So this one here, y greater than 2. That becomes our range for this kind of a graph. What about this one that is facing down, that is not smiling, that is sad? Let's look at it and see what we get. So here y is going to be equals to x negative x squared minus 6. Now, when it's y equals negative x squared minus 6, we want to talk of the domain here. Domain remains the same. Domain, remember what happens? The domain is occupying all the x values. X element of real numbers, x element of what we call negative infinity to positive infinity. What about in this side here? What are we going to have here? We can see that in the terms of the range, y is occupying negative 6. It's less than negative 6. So our range here is from negative 6 downwards. That's what is happening here. So y is equal to negative 6 going down. It's below negative 6. That's what we see there. Okay. So what I just need to add there, is actually the or equal to. So here we're including the value. Or equal to, also there, or equal to. Okay, so in this case, you can also rewrite this. For example, here in terms of the infinity, we are saying it's actually from 0, y element of from 0 to infinity. Then here also y element of from your 2 to what you call positive infinity. Then in this case here, it's gonna be y element of what you call from negative. So we are saying from negative infinity to negative 6. That's how we write. So in this case here, we are starting from 2 going up. So the positive infinity is going to be up. But in this case here, on the negative 6, we are starting from negative infinity up until 6. That's where we end. Okay, that's what it means here. Then I just want to also indicate what is it, axis of symmetry. But this axis of symmetry is just x equal to 0. Axis of symmetry for in your case here now in grade 10, you just need to know that axis of symmetry, x is equal to 0. Axis of symmetry is where the line that divides your graph into half. So into mirror images. So line that so here axis of symmetry is actually x equal to 0. So here this line, the y-axis. So here axis of symmetry x equal to 0. So in this case, it is the y, what call axis. That's what we know. Axis of symmetry is x is equal to 0. Don't stress yourself for now. Now let's look at also finding the equation. So finding equation of a quadratic what called a function. Now in this case here, you are given the y-intercept. So here it's y-intercept that is given, and a point. How do we deal with that? When you're given y-intercept and a point, we know that from our equation, y is equal to x squared. Sorry about that. Y is equals ax squared plus what called y equals x squared plus q. Now we have got the y-intercept. We also have a point. Now what do we do in this case? We want to find what is it, the a and the q. That is what is short. So the question here is that what is a and what is our q? That's the question. Now, from our knowledge of the equation, we know that y is equal to x plus q. Let's just x squared plus q. Let's just rewrite here. Y is equals to ax squared plus q. Our q is our y-intercept. So we know that q is a y-intercept. So y-intercept is equal to -3. So here you can just put it in. Q is equals to what you call -3. Okay, because this point here is 0 and -3. And now we are saying when x is equals to 0, y is equals to -3. Okay, now we have got q, we have got y, we've got x. We are now using this point now. So this is coming from your intercept. And now let's substitute this point here for x and y now to find our a. So what we're going to do here now, we're going to say our y is going to be -6 is equal to, what is our a? We don't have a. What is our x? We have it, -2 squared a plus what? -3. Now we take this one here, -3. We can -3. We take 3 that side. It's going to be equal to what? It's going to be equal to what called -3 is going to be equal to what do we have here? We have got 4a. Now when you've got 4a, we are going to divide by divide by 3 by 4. So a here is going to be equals to -3/4. So -3/4 is actually our a. So now we can now rewrite the equation now and say, okay, what is our equation? Our equation is going to be equals to -3/4 a squared -3. So this negative here, it's actually, remember what is happening here with this one here? It means that it's in the shape of what is frowning. So that's what happens. So always know that, is your answer correct? How do you know that? You check the value of a. Is it negative? Is it positive? Based on where the graph is facing. Okay, so that's how you get it. So you know that first thing, you take the y-intercept, you put it as q. Second thing, you substitute the point to find a. That's it. That's how you get the equation given in the intercept and actually a point. What about this part here where you are given the x values, the x-intercept? So in this here, you are given the x-intercept and a point. Okay, now when you're given this, you need to use this kind of this equation. You need to use this equation here. Y is equals to a x minus x1 x minus x2. Now what is x1 minus x2? This is the point. So here x1, these are the coordinates that were given here. So here x1 and x2 are your x-intercepts. That's what we know here. X-intercept. These are your x-intercepts, x1 and x2. Then What about x and here x and x? What you call these are your what you call this is coming from your point. Okay, this is your point that you are given. So in this case here, this is a point that you're given. So here the x, this one here, x and x, these is your point given. X value of the point given. That's what we know. So here, these are your code, your intercepts, and your A, you know what to do with that. So now let's substitute also this y is also a point you are getting from the point. So what you are doing here, when you are substituting this, you're going to find you are looking for A. When you substitute everything here, you are looking for A. So what you're going to do in this case, you're going to say, okay, what is our A here? What is our Y there? Our Y is equal to 2. So it's going to be 2 is equal to, what is our A? We don't know A. What is our X? X is negative 4. Okay. Now, what is the first coordinate? It's going to be minus and minus. Sorry about that. It's going to be minus in the bracket, minus, small bracket here, minus 3. Then here it's going to be negative 4 again. What is it? Minus 3. So in this case, this is the 3 that we, so we have got this 3 here and this 3 here. So this one here is negative, this one is positive. So this is the first 3, this is the second 3 here. Now, what are we going to do now? We're going to say, okay, 2 is equal to A, negative 4 plus 3, negative 7. So in this case here, we have got negative 7 here, we have got negative 1, we're going to get negative 1 here, negative 1, and here we're going to get negative 7, and there is going to be 2. Then what is going to be this? Is going to be negative, is going to be positive, so it's going to be 7A equal to 2. Then what is our A now? Our A is equals to 2 over 7. So now once we find our A is 2 over 7, what do we do now? What do we do now when we find our A is 2 over 7? We now need to put in what call our values now. So now we put in the values now. Y, we return the value of Y there. A, we now have it 2 over 7. And you can see that is also facing up. So it's supposed to be positive. Then in our bracket, what are we going to have? X minus, minus going to be X plus minus 3 there. X plus 3. Then also here, X minus 3. Okay, now that's we're substituting the values now. When you have that, what are you going to do? Let's see what we get here. This is going to be equals to 2 over 7 in bracket x. This is the difference of two squares, guys. X squared minus 9. Okay, x squared minus 9. We take the 2 over 7 inside. It's going to be equals to 2 over 7x squared minus 2 times 9 is going to give you 18. So it's going to be 18 over 7. And there is our y. So we have our equation there. So that's how you get the equation, guys. That's what you're supposed to do when you're given x-intercepts and also a point. That's the equation that you must use, and I hope you understand that. Now, let's move on to the next part there, where we are sketching. Now, what do we need to master when we are sketching? What do we need to master when we are sketching? When you are sketching, you must know the intercepts. So if ever there are intercepts, you know that you need to get them. Now, for example, here, so you are using the dual intercept method where we are saying if, so find intercept first. So when you're saying intercepts, it's y and x. But if, for example, for the first equation here, what do we know about the intercepts here? We know that the y-intercept, y is equal to what is it? Y is equals to 4 when x is equals to what? 0. What about when x is equals to when y is equal to 0? Let's say when y is equal to 0. When y equal to 0, let's see what we find here. when y is equal to 0, we're going to say x squared is going to be equals to -4, and x is going to be equals to root of -4, which in this case here is, you can't have a root of a negative. So here, let's just try it here, root of -4, it will give you error. So it means that it's something that does not exist. So what does it mean? It means that it never touches the y-axis. It will never touch the the x-axis. Sorry, it will never touch the x-axis. So the x-axis, it never approaches the x-axis. So what does this mean? It means that does not approach x-axis. That's what it means. So now from now we know that does not affect the x-axis, so we're not going to worry about x-intercepts in this case. So we're going to draw our graph now and say, okay, our graph is going to be equal to, okay, our graph there is going to be equals to, I want to take this so that we can have more space on top there. Okay, let's have more space on top. Okay, then we have got our y-axis there. Now, so we're going to have our x squared plus 4. So x squared plus 4 is going to be like this. So now, what about the y is equals to x squared plus 4? Now check here. We have got the 2. It means that it becomes what called, it stretches our graph, or it becomes what called narrow, or it shrinks our graph. So it means here is this widening is narrowing the graph. So in this case, the graph here of 2x squared is going to be equal to like this. It's going to be touching again at 4, then goes up. That's what's happening here. Then here we know that this is 4, and that's the graph of y equal to 2x squared plus 4. And this one here, y is equals to x squared plus 4. So if you had asked to draw them on the same set of x's, that's how you should do it. Now, let's also talk of the domain here, domain and range. So domain, remember, domain x element of real numbers, okay? Or you can say, or don't put both of them. You don't put both of them, please, guys. Negative infinity are what called to infinity. That's what is happening here. What about the range? Range here is going to be equal to y greater than or equal to 4. Or you can say y, what is it? Element of what called 4 to infinity. That is what's happening here. Okay. And what is our axis of symmetry? Axis of symmetry. Axis of symmetry. We know that this one is going to be x equal to 0. So that's our axis of symmetry. Now let's look at this one here. The other graph, what we have here is x squared minus 5. Now it means that we can find our y-intercept when x is equals to 0. When x is equals to 0, y is equals to -5. So our y-intercept, we have it, because that's what we know. Our y-intercept is that. And what about x-intercept? When y equal to 0, what do we have here? We see that x squared is going to be equal to 5. And in this case now, we can find the root of that. So x is going to be equals to root of, so it's always plus minus root of 5. So in this case here, our value there, if we say root 5, let's just cancel that, root 5, we have that, and we don't want to stress ourselves and write the decimal here. So you're just going to say your value here is going to be plus root 5 or negative root 5. That's what it means. So these are x intercepts now, x intercepts. Then when it comes to sketching now, what do we do now? We're going to come here and say, okay, let's draw our graph. Our graph is like that. So our graph touches. So here we have got the x, here we have got the y. Okay, then we've got the origin, and there we have got -5. Let's just use another color there. We have -5, and there we have got -√5, and there is +√5. That is what's happening here. And what is our domain in this case? Our domain, x element of real numbers, okay? Or we can say x element of what is called -infinity to +infinity. What about what is it? What about the range? Range. Now with the range there, you need to know that y is greater than or equal to -5, or y is element of -5 up until infinity. That is what's happening here. Okay, so that's what all. Then axis of symmetry. Axis of symmetry. Axis of symmetry is know that x is equal to 0. Then again, another thing again, our turning point. Our turning point. We now know that it's just equal to q. It's equal to q, so it's 0, negative. What is it? A -5. That's our turning point. So turning point for quadratic functions. Turning point for y equal to, for the graph of y equal to x squared, what call plus x squared plus q. We know that this turning point is going to be equals to what call 0 and q. 0 and q, that's our turning point always when we are dealing with quadratic functions for this what call type of graph. Now let's move on to the last part of our session today. If f of x is equals to x squared minus x plus 1, determine the value of what call of f2. So f2, what you are just saying here, where there is x, we are putting 2. So here it's going to be 2 squared minus 2 plus 1. Then here 2 squared is 4, times 2 is 8. 8 minus 2 is 6. 6 plus 1 is 7. So our answer will be 7 there. What about if it comes in this case here, where we are saying is 2x? So it means that where there's x, we are putting 2x. So it's going to be f of x, f of 2x is going to be equals to 2 in bracket 2x squared minus in bracket 2x plus 1. So in this case now, 2 is going to be equals to here 2 squared 4x squared minus 2x plus what? Plus 1, which is going to be equals to here 2 times 2 is going to be what call 8 x squared minus 2x plus 1. So I will leave you to do this one and this one, guys. Thank you so much for today. Don't forget to subscribe to our YouTube channel and also follow us on Facebook and Instagram. On TikTok, it's what called Tatenda Story. Okay, not your tutors. Thank you so much. Until next time. Bye-bye.